Welcome to Study Loop.
This is the answer to Chapter 13, problem number 50 from the Smith Organic Chemistry textbook. And so in this problem, we're given a starting molecule and some reagent conditions, and we have to determine the molecule that will be produced by treating this starting molecule with these two reagents. And we are given mass spec and IR data to help us. However, the mass spec and IR data are more confirmatory in this problem. So I think that the way to approach this problem is that you have to know your reagents pretty well and be able to determine what thionyl chloride and then this alcohol would do to the starting material that we're given. And so I have drawn that out down here. So treating this carboxylic acid with thionyl chloride is going to get you to the acid chloride, which I've drawn here. And then treating that with this alcohol is going to displace the chlorine and get you to this ester. And so that is the structure of molecule X. And now we can look at the spectral data that we've been given and use it to try to confirm our prediction that this is molecule X. And so I'm actually going to start with the IR data. And so the first two peaks that we're given are really just CsP3H bond peaks. So they don't really tell us much. I mean, obviously the molecule that we've drawn has several carbons that are sp3 hybridized with hydrogens bound to them. But many molecules do, and so that doesn't really tell us much. However, looking at this peak at 1739 wave numbers, we should be able to tell that that corresponds to a carbon double bonded to an oxygen. And indeed, in our predicted molecule X, we do have a bond that could account for that IR stretch. So that's good. And so lastly, we'll look at the mass spec. So we have a molecular ion peak of 144. And so down here, I've drawn out some possibilities for what 144 could be. So if we assume that we have one oxygen in this molecule, this would be our math. So 144 minus 16 for the one oxygen is 128. So a possible formula there is C10H8O. And so I'm not going to rule that out right away. However, we are pretty sure at this point that we have the correct prediction for X. So following that line of reasoning, if we assume that this 144 accounts for a molecule with two oxygens in it, we get 144 minus 32, and that gives us 112. And so a possible formula there could be C9H4O2. As I've said in other problems, I think that that's a good way to try to fill in a mass spec. So we have two oxygens, so we subtract 32 or 16 for each of the two oxygens. That leaves us 112. So what's the most carbons that we could put in? It would be 9. And that would give us 108 of this 112. But then we would only have 4 hydrogens. So our formula would be C9H4O2. And just briefly to check to see if that's a reasonable formula, we could calculate the hydrogen deficiency index, which I've done up here in red. And so remember to do that, a simplified version, you're going to multiply the number of carbons that you have by 2, add 2 to that number, and then subtract the number of hydrogens that you have, and then divide all of that by 2. And so for this problem, it would give us 16 over 2, or 8. So that's telling us that there are 8 double bonds, 8 rings, or some combination of double bonds and rings adding up to 8. And that seems pretty unlikely. It would be hard to draw a simple molecule with only a mass of 144 that had, 8 double bonds or some combination of many double bonds and several rings. So instead, what I did next was I just dropped a carbon and added 12 hydrogens. So C8H16O2 rather than C9H4O2. And when we look at C8H16O2, we see that the hydrogen deficiency index for this formula is only 1. And C8H16O2 also happens to fit what we've drawn here for X. And so I think that that's the correct formula. It agrees with everything else that we've said so far based on what we know about the reaction conditions and based on this IR that we're given. So I think that this is the correct formula, and I think that our prediction for X is valid. And I believe that this is the answer. And so that is the answer to Chapter 13, problem number 50.